Okay, so first things first. What was life like when you were growing up? Like, what experiences and what different types of situations helped build you?
The most important thing was that my dad was in the Air Force, and so first it meant I moved around a whole lot.
Mm-hmm.
And second, it meant that the places where I lived normally had lots of airplanes around them. So for example, we lived in, one of the places we lived was in the town of Bitburg in what was then West Germany. And we lived in an area where there were two American air bases right next to each other. One was Bitburg Air Base, which I think is now closed, and the other is called Spangdahlem, which is actually still there. And so there were F-15s and F-4s flying all around us all the time. After that, we were stationed in North Dakota for a year and a half. And so my dad was working on the B-52 bombers that were stationed there. And so I grew up around airplanes thinking it was normal. In many cases, big ones. Occasionally, my dad would pull some strings and he would give his family a tour of where he worked. So we'd go into these really big hangars and we would climb up inside a B-52.
Wow.
And these planes are gigantic and there's no room in them. You'd think that there'd be room in these things, and there isn't because it's all full of equipment. But as I was growing up, I was just fascinated by aircraft, and I thought that, you know, some kind of career where I'm designing or making or working on these things would be absolutely just wonderful. So that was kind of what got me started moving in this direction while I was growing up.
Mm-hmm.
Well, like during your life, since you were like always interested in planes since you were little, did you ever were you ever interested in something else that made you like want to think of a different career than engineering?
I think I was like most kids in that I wanted to be an astronaut, and I wanted to be a doctor, and I wanted to be, you know, you name it. So I entertained lots of different ideas. This wasn't a case of me thinking I must work on planes and that's the only thing I will ever do. So I had plenty of other interests, but I kept coming back to the desire to build something, to engineer something, to make something.
So what did you do? What were you thinking during high school, and then right after high school when you were getting into like the career you wanted to do, like being an aerospace engineer and stuff like that? Like,
well, during high school, I don't know that I was necessarily focused or obsessed on my career at that point. I wanted to do something involving either science or engineering. That's pretty much the extent of it. Mostly in high school, you think about girls.
Yeah.
And you have your studying, and you think about your studying as well. But
Yeah.
I wasn't, you know, the future still seemed a long way off at that point. When I got into college, I went through this process where I kept changing my major. So when I started out, I entered college as a physics major because physics is one of those general all-around good things to do where if you know your physics really well, there's very little you can't do in the field of mathematics or technology. It provides a very good preparation for a lot of different stuff. But almost as soon as I entered college, I went to San Jose State. Almost as soon as I entered college, I discovered that the engineering department was off of impaction. Basically what this meant was the engineering department at San Jose State gets so many applications from so many people that the programs are always, or almost always, filled. They're impacted. That means that it's hard to get into them because there are simply so many people that want to get into them. Well, for whatever reason, I know not what, in 1989, when I started, all the engineering programs, for whatever reason, were off of impaction. They had room. And so I'm like, great! So I jumped in and changed my major to aerospace engineering. And so I took the engineering classes for about 2 years or so. And then I discovered, and I was thinking about this, and there were some of the math classes that really I wasn't doing so well in. And also I was starting at that point to look at the way the careers were, what careers were available. And this was just after the end of the Cold War. Peace had broken out all over, and so a lot of military budgets were being cut back, and that meant there were not nearly so many opportunities for engineering of aircraft, and a lot of aerospace engineers were being laid off. And I was thinking to myself, I'm studying in a career that, I'm not sure what the future is going to be like. So I changed my major again, and I changed it to computer science. Because if the opportunity still came up to do work on aircraft, there's a lot of software on modern aircraft. There's a lot of programming that needs to be done. We have a lot more software engineers where I currently work than we have aerospace engineers. And I can talk about that later if you want to understand what's going on there. So I changed it with the idea that if you have software, you can go in lots of different directions. If opportunity comes to work on aircraft, you can do that. But if the opportunity does not come to work on aircraft, you can still work on something else. You can still work on many other different kinds of systems, or you can go into data management, or you could go into developing of applications, or lots of other things. So it gives you more opportunities. That's kind of what I did when I was in college. And it was probably a good decision. My first job after college was actually at a financial services firm.
So what'd you do then?
What did I do there? This particular company had a product that it was risk management. So imagine that you are a fund manager. It's your job to take all the investment funds from your investors, and your job is to pick out stocks and or bonds and so forth and create a portfolio that you expect is going to make lots of money. Well, there's risk in any investment. And the danger as a fund manager is that you will invest in a lot of the same kinds of stocks, and then say the market in oil collapses. Well, you've got a whole bunch of oil stocks, you lose a lot of money at once. The fact that you diversified across lots of companies doesn't actually help you when the entire industry goes kaput. So trying to analyze what kind of risk you have. Are you overexposed to large stocks or small ones? Are you overexposed to certain market sectors as opposed to others? Do you need to diversify by getting out of this set of stocks and more into those? There's that kind of analysis is what this company specialized in. And in order to provide their product, we had 3 different kinds of programmers in the company. We had the software engineers that created the application that ran on our customers' desktops. Then we had our research group, and they were the ones that came up with the financial models and the economic models. They're the ones that did the huge linear regressions where they came out and calculated what the risk factors were. And then you had my team. And the group that I was on there, we were data management. It was our job to collect every bit of information we could on every stock traded on Earth and store it in databases in such a way that it could be retrieved and then put through the models created by our research team. So there was a lot of collection of data, and the data that you get from vendors often has mistakes in it. So you have to do some kind of checks and cross-checks from various multiple data sources to see who's right and who's wrong, or checks to see if all of a sudden the stock loses half its value in one day. Well, is that real, or is that a stock split that just got missed? So there's a lot of automation of processes to make certain that we get the data from our vendors, that the data is cleaned and processed to look for errors, make certain that it's stored, make certain that we take it out on a daily or monthly basis, depending on the product, take it out of the databases and put it through our models to produce the value-added data that we're producing, package it all together and get it out to our customers on a daily basis, And if you don't get it out on time, they start complaining. You start getting phone calls in your office saying, where is our data now? Because they're paying a lot of money for it.
Yeah.
So that was the group that I was in. It was data management. And I was one of the people developing the automated processes that would collect the data, store it, pull it out, and send it on.
So how did you, going from that, how did you get to composite engineering?
It took a couple of steps. So at this point I was writing not so much what was called software. We were writing scripts. We were writing processes behind the scenes. The stuff I was working on at the time was not the stuff that goes out to the customers. It was all in-house. It was not pretty. It was not all prettied up. It didn't have nice graphical user interfaces. It's just stuff that runs on a server back at the shop. Okay.
So like BIOS, just
scripts. So scripts are very high-level programs. You've got your operating system, and then you've got your hardcore programming languages like C, Fortran, although that's not used very much anymore, Java, things like that. And then above that you have stuff that's like Perl. These are just text files that contain computer commands, and then you feed it to an interpreter that reads through it line by line and picks out stuff. So that was kind of the level that we were working at. It was lots of scripts, shell scripts, and if you do any programming on a Linux environment or whatever, you'll learn what a shell script is. Batch files, DOS batch files, very high level stuff. But the fact that it was high level doesn't mean that it's necessarily easy to write, because there's a lot of it and there's a lot of data. Also, SQL, if you're at all familiar with that, it is a language that is used for working with databases. It's been around for a long time, ever since I was in college, if not before. And it's all about creating queries. You want data, give me the name of every person that worked on this project between the years of this and that, whose last name begins with the letter R through S. Well, can you write a query to go into the database and get that information for you? That's what SQL is. And it's something where if you're going to be working databases, you got to know it, and you got to be good at it. It's still used because it's just a very powerful thing. So anyway, that's the kind of stuff I was doing at this company. It was called Bara Incorporated. The company doesn't exist anymore. It got bought out by Morgan Stanley several years back. Well, anyway, after 4 years at this company, and I was fairly comfortable there, I got engaged. And the thing is, I was living in Fremont at the time, and I was working up in Berkeley, and my girlfriend lived in San Jose. And so I was spread out all over the map, and I decided I need to consolidate. So I started looking for a job in the San Jose area, closer to where my fiance was. And I managed to land a job at Northrop Grumman, so moving in the direction of aerospace there. What I got hired for there was for a discipline called configuration management. Configuration management is one of those jobs where it's actually easier to get a job doing that than to get a job doing software, because it's one of those jobs where no one wants to do it. So if you say, yes, I'm willing to do it, people are like, okay, we'll hire you. Configuration management is essentially, it's keeping track of all the changes that happen in software. So think of a librarian. A librarian's job is to keep track of all the information that's in a library. You've got a whole bunch of books there, and some people are checking books out and checking books back in. And it's your job as a librarian to make absolutely sure that you know where every piece of information is in that library at any given time, and to look for problems and so forth. Well, configuration management is kind of doing the same sort of thing for software. So you've got a team of engineers, and you've got a program that they're working on where there might be dozens or hundreds of files of source code that all get compiled together into your executable. All those bits of software keep getting changed, in many cases by multiple engineers. And at some point, your customer, which in this case would be someone in the U.S. government or the military or whatever, comes back and says, okay, we liked the version of the software that you delivered last May. Can you reproduce it for us? Well, all these engineers have been making changes to the files the whole time. How do you produce the same version that went out? Well, hopefully you have it on a tape somewhere. You've stored it off onto some kind of hard storage, which is sitting in a box somewhere so you can grab it. But hopefully you're also using a tool like, there's one called ClearCase that we used back at Northrop Grumman. There's one called Star Team that we use right now, where these are keeping track of your software and all the changes of the software. And so when it's time to make a delivery, you get things the way you like it, and you essentially take a snapshot in time and you label everything in the database. It's a database of code, basically. So as time progresses and more changes are made, well, you still got that snapshot in memory, and the system, your ClearCase or your Star Team, knows that, okay, the version that you delivered in May is this file, and this version of this file, and that version of that file, and so forth. And so you can reproduce your entire development environment. So you can keep track of all the bugs that have been fixed. That's another big part of it, is you have a bug tracking database so that you know that, yes, the version that went out in September has the bug fixed, but the version that went out in August did not, and so forth. So I got into Northrop Grumman doing software configuration management, and I did that for several years, and eventually just kind of managed to transition. When you get into a company, it's often easier to get into a company saying, I'm willing to do anything, than it is saying, I want to be a software engineer. If you say, I want to be a software engineer, they say, well, we don't need software engineers right now, we need configuration management. If you say, I'm willing to do the configuration management, they say, great, we'll take you. And then after a couple of years, then you transition to being a software engineer. So I managed to make that transition. And so I continued to work at Northrop Grumman, working on a variety of different projects, many of which were classified, and I can't tell you, because then I'd have to kill you, and there are 3 of you and 1 of me, and I can't do that. So, 5, well, yeah. Okay, I'd lose. So I'm not going to tell you. Well, the thing about the defense industry that you have to understand is that you're doing contracting work. And what that means is, although you are being paid by, say, Northrop Grumman is getting paid by the US government. And what's happening is the money that they're getting from this program is paying the salaries of the people that are working on that program. So what happens when the programs start drying up? Well, Northrop Grumman then cannot maintain its workforce unless it keeps having new programs coming in. And about 2011, they were starting to have fewer and fewer programs coming in because of just kind of the environment in Washington. There wasn't a whole lot of new work available. And so they had a big round of layoffs, and they had to let go a lot of people. And I was let go in 2011. So I started a job hunt and just discovered on my first day when I was laid off, I discovered that there's actually another aerospace company in the area that I hadn't even heard of before. It's called Composite Engineering Incorporated, and they were looking for testing engineers. Now, I wanted to do software, but thinking back to that bit about the configuration management, if you say, yes, I'm willing to do testing. In fact, I've done this testing on stuff at my previous job. Well then, you're much more likely to get in. So I interviewed at CEI, and at first they didn't accept me, and I was totally bummed because, great, now I have to go start looking for financial services firms and other things, which aren't quite as fun as for me. But it turns out that CEI was also going through a transition period. There was some political infighting within the company, and when you get out into the work world, there's always political infighting within whatever company you go to. Some are better than others, but there tends to be a lot of infighting, especially in defense type companies.
Mm.
And about January, Composite Engineering wound up with a new director of software engineering. And she looked at the schedule and she looked at the programs that the company was working on, and she said, we are way short of people right now. So she went back, and this is one of the only times I've ever heard of this ever happening. She went back and she looked at all the rejected resumes, people that they'd interviewed and not hired, and my name came up. She asked around. There was at least one guy at the company that had previously been at Northrop Grumman and knew me, and he said, I think this guy could do the job. So she called me back in to talk to me in January. So this is about 4 months after I'd been laid off. And we had a brief conversation, and she said, I'm going to put together an offer for you. I'm like, wow, okay. So that was about 3 years ago, and I've been working at Composite Engineering ever since.
So,
Mm-hmm.
what kind of successes have you gone through since going from growing up to composite? Like, what more have you learned about engineering and stuff since you've been at composite?
Well, the stuff that I'm doing at Composite Engineering is development of a flight control system for a target drone. So, just so that you know, Composite Engineering is an aerospace company that develops target drones for the U.S. military and for militaries in other countries. Target drones, these are things you launch them off a rail, and then the U.S. Navy is the customer on the program I'm working on right now, will try and track it and try and shoot it down. And they do this for training of their people, but not just for training their people, also for testing their defensive systems. Can we shoot down a sea-skimming missile? So our job is to produce a drone that acts like a sea-skimming missile to see if, so that they can test their systems and see if they can shoot it down. So when I got there, there was a lot of work being done on the flight control system of this plane. This drone, but as I mentioned, things had been in disarray in the company for a while, and we had a new director of software engineering, and what she needed us to do was to start developing test plans. These test plans, okay, the military always thinks in terms of acronyms. So you have a document called a software test description, which has a really unfortunate acronym. So people would tell me, what is your job? And my answer would be, I'm trying to develop an STD so I can present it, so I can give it to the Navy people when they come. So that was my job. I was developing this document called a software test description. So what you have is, the Navy is, they will give you a list of requirements. The plane must be able to do this, it must be able to do it in this way, it has to be able to fly at this altitude and at this speed, and it has to be able to do this, and it has to carry these kinds of payloads and use these kinds of countermeasures and so forth. A long list of things that, and then when the overall design gets made, those Navy requirements get broken up. So now we have a flight control system. So we derive requirements from that. This flight control system must be able to handle these situations. It must be able to continue to navigate properly when you are 6 feet above the water. It must be able to do all this kind of stuff. And for every requirement that we come up with, we have to show the Navy that we have addressed that requirement. So how do you show the Navy that your simulator that you're developing properly simulates the entire flight envelope of the plane? Well, you can do it a couple different ways. You can try and produce a test where you hit every part of the flight envelope. Or what you can do is you can do it through analysis. You can pull open the code and show them, this is the way we calculate our aerodynamic coefficients and so forth. And as you can see by looking at these equations, we are covering the entire range. We are looking values up in the table, and the table has values that go all the way from 0 knots all the way up to Mach 1.2 or however fast you're going. And so we can pull out the numbers that we need from the table. So anyway, you're asking about successes. The first thing that I was very happy about was about 6 months after I joined the company, I led the Navy representatives through qualification testing. So I basically took my software test description documents and I produced a couple of them for different parts of the system, and we went line by line and we ran every single test, and we showed the Navy that yes, in fact, we have met, or we have addressed this requirement, and we have addressed that requirement, we've addressed that one, all the way down through that. And the Navy went with it. It's like, that was a success. So after that was done, there wasn't as much immediate need for the qualification testing. So I was then transitioned into software engineering. Yes. So I consider that a success.
Yeah.
Although I keep getting sucked back into the qualification testing. The two parts of the system that I was required to test were the navigation system. And let me tell you, that thing, the way it works is voodoo. And then there's the simulator. Now when I say simulator, the simulator is not like you think of a flight simulator where you're sitting at your computer and you've got your joystick and you're having a good old time. The purpose of this simulator is not so that you can have the experience of flying. The purpose is to try and convince our flight control box that it is flying, so that you can test it and make sure that it's doing the right things. So you're trying to get your flight control system to pretend that it's flying. And so we have long lists of requirements for both those systems, and I had to develop the test procedures for both of those. So I was at the company when we had our first flight and our second and so forth. We had a whole bunch of flights that were done on our own company's dime, because we're not just developing it for the US Navy. This platform has also been purchased by a couple of international customers. And so we wanted to test, we had to get the plane in the air because we were having some development difficulties. And so we wanted to get it in the air and fly it and see how it worked and see what broke and see what... so we made a couple of smoking holes in the ground. But we eventually got to the point where the smoking holes in the ground just kind of stopped. And so the plane continues to fly. And we've had some successes since then. And so we think we've gotten a bunch of the bugs worked out. And we consider that a success as well. So we have entered a later phase of development where we now are reasonably confident that the plane flies and that it's not going to leave smoking holes in the ground. And so now we're starting to get into other systems like payloads. So this plane that we're working on is supposed to carry countermeasures. So when the Navy is trying to shoot it down, we start firing off chaff and flares to spoof the missiles. We start turning on onboard electronic jammers. We start, and sometimes we want to make the plane look like a bigger plane on radar and so forth, and so we have other things that can increase the radar signature of the plane, special reflectors or special emitters. We have to be able to support all of that. And so right now our big push in our development is making certain that all these things are properly developed. And this is something where I am heavily involved in that. I'm one of the lead developers on that part right now. I don't want to say lead because that involves like giving orders to other people. So I'm still assistant vice sub peon. But they are working in, a lot of this development work is happening in my area of expertise at the moment. So payloads is one of the things that I've been working on, off and on with for the last couple of years. And so now we're doing a big payloads push, and people keep saying, Tim, how does this work? And I say, well, let me tell you. And I explain it to them, like, ooh, so that's kind of nice.
So when you said you were testing it in there, was that just in simulation, or have you done it in like physical, real plane?
We have done maybe a dozen or so real world flights. And we've had, I think, at least 3 smoking holes in the ground. In the simulator, we produce smoking holes in the ground all the time.
Yeah.
Imagine getting simulated.
But in real life, we've had about a dozen or so flights, most of which were flown at a test site in Nevada. It's actually very near Area 51, and so we and it's very near the Nevada nuclear test range. So there were some places where we were flying where if we crashed the plane, we would not be permitted to go get it. Not just because it's a highly secure facility, but because it's radioactive and they don't want you going there. So
Did you see aliens?
we have not seen aliens.
You can't tell you that anyway.
If I had, I'd have to kill you. So we had one flight where the airframe had some instabilities where it would start shaking. It would start vibrating, and and it would go faster and faster. And the tails are trying to compensate for this because the plane would detect it's going up now, and so the tails would try and force it back down, and it was just it was the automated equivalent of a pilot-induced oscillation. So as it's trying to correct, it's being a little bit too slow, and it hits one of the resonating frequencies of the plane, and the tail ripped off. One of the elevators just came right off the plane. The trouble is, this being an unmanned plane, which is a good thing, but it's kind of hard to tell from the ground what's happening up on the plane when it's completely automated. Basically, you can only tell things if you've got a sensor right on that thing. And we don't have a sensor saying, dude, your elevator has departed from the plane. We don't have a sensor. All we knew is that the plane suddenly is out of control and it's tumbling. Now, there were actually some cameras mounted on the plane, but they were only recording footage that would go into that would be stored on the plane, and then we would go out to the plane and collect it afterwards, and then we could get the data off of it and so forth. So there is video footage, which I've seen, of the tail going off the plane. But at the time, when they were actually trying to fly it, they didn't know that the tail was gone. So they were trying to do their recovery maneuvers. They were trying to do, okay, how do you recover from, if you flipped over, well, you do this, and oh, it's not working. Why is it not working? And in the process, while this was happening, the pilots lost track of the height of the ground. See, the thing is, they were accustomed to flying on the simulators and so forth, where the surface is sea level. It's 0 feet. And we're flying over the Nevada desert, where the altitude of the ground is like 4,000 feet. And so they were trying to recover and not realizing how close they were getting to the ground. And they said, okay, this isn't going to work. It's time to hit the chutes. And so they hit the button to hit the chutes. And it was like one of those Roadrunner cartoons where Wile E. Coyote goes over the cliff and he's got the parachute and he always hits the ground and then the parachute comes out. That's exactly what happened here. It's so funny watching it from the onboard video. The plane goes boom, and then you see the chute go and it was funny. It was sad, but it was funny as well. It's like, oh, Jesus.
So, when you're looking at, I assume there's a black box on the plane, right? So you can get flight data and stuff.
There's something that's essentially equivalent. The flight control box has a little slot in it for an SD card, which you install, and everything just gets written to the SD card. So yes, there is.
So when you're looking at that, can you plug it in and then look at all the reports that it took from the flight, and then you can say, oh, that's why this happened and stuff like that, so you could find out why the oscillation from the plane is going on or whatever, and then you can kind of reverse engineer it to work. Yeah.
The answer is yes. and that's exactly what happens. What goes onto that card, that also happens to be one of the specific areas where I've done a lot of coding on that thing. In fact, I've had to debug the code to put stuff on there. Pretty much, okay, the flight control box receives messages from lots of other systems on board the plane. You've got the transponder, which is the way it communicates with the ground control station. You've got the engine control module, the engine control unit, which you send it commands from the FCS core, and it commands the engine, and the engine will report back things like engine temperature, RPM, so forth. You've got the power management control unit, which handles electric power to all the systems on board the plane. You've got the actuators. You've got that controls the elevators, and the ailerons, and so forth. So all the control surfaces. You've got the payload interface module, which controls the wingtip payloads. All these things are communicating on serial buses. All these are communicating on serial buses back to the flight control system. And so the flight control system has all these messages that tell it the state of everything that's going on board the plane. Every one of those messages, every one of them gets written onto that card, along with the timestamp. So we can tell, so we can tell by unpacking the contents of this SD card after the flight, everything that happened from the point of view of the flight control system, including the navigation messages. So if the plane is going tumble, 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 we know, okay, at this moment it was like this, and at this moment it was like this, and so forth, all the way down to the ground. So we know all that information. So as long as we can get to the plane and recover that little chip, we're good to go. That doesn't help us if we land in the water and it sinks, though, which happened on one of our planes. Or if it lands in radioactive territory. So try and avoid that.
Yeah.
It's okay.
So, what kind of fears do you have right now?
What kind of fears?
Yeah.
Well, I will say this. As much as I enjoy working in aerospace, anybody who works in the military field is in continuous fear of layoffs. That's just the way things go. If your company does not get enough, if your company does not get enough work from the government or from international governments, your employer will not have the money coming in to pay for you. And the way it works is, if you're on this program and the program gets canceled, well, there might be other programs coming in, and if there are, you try and get yourself assigned to those. But if you don't, eventually you go on overhead, and if you stay on overhead too long, the company ultimately has to let you go because they don't have the money coming in to pay for you. And so we are not as highly exposed to the local economy. So if business is bad in the Sacramento area, just for example, lots of other people might get laid off, but we wouldn't get laid off because our money doesn't come from the Sacramento area, it comes from Washington. But we are highly exposed to what goes on in Washington. So if you get a president, an administration, or a Congress or whatever that hates the military and thinks we're putting way too much money on this, the jobs of lots and lots of people in the defense contractors become at stake. And so that is probably the biggest fear, is that the programs will eventually dry up, and when that happens, you're out of a job. So that's probably the biggest fear. And there's a fair amount of technology in the Sacramento area, but it's not like in the Bay Area. If you live in the Bay Area and you're a software engineer and you lose your job, well, there are companies all across the countryside, and it's just a matter of finding one. In the Sacramento area, it's a little bit tougher, and most of the work that you have out here is for, well, you do have some. You've got Hewlett-Packard that has stuff in the area. Intel has a big plant in Folsom. So there are some decent companies in this area. But there's not as much defense for aerospace.
So, Have you considered like looking at NASA as a possibility for software development, or is that different from?
Well, I am not the kind of person who enjoys going job hopping. So when I have a job that I'm satisfied with, I generally stay satisfied with it for a really, really long time. If I were to not have my job at CPI anymore, I would certainly look around to see what other jobs are out there. Now, NASA is a place where it'd be kind of nice to work for
Yeah.
NASA. But NASA does not have a facility that I'm aware of in the Sacramento area, which would mean that if I were to go in that direction, I would have to uproot my family. There is NASA Ames in the Bay Area. There's NASA in Southern California, and then there are places in like Huntsville, Alabama, which is interesting because my wife has extended family that lives in that area. So Huntsville, Alabama is a big NASA site, and then Texas has a lot of NASA as well. But that would involve, like I say, uprooting my family, and I'd rather not.
Yeah.
And so,
Well, yeah, it was more of like, if you had the opportunity to work there, would you? And if, in terms of the positions they have there, like, would you be well equipped from previous jobs to work there?
it probably depends on what exactly they were doing there. Although, like I did mention before, software engineering tends to be a bit more flexible than, say, aerospace engineering. Because if you know how to program, if you're a good coder, there are lots of different fields that you could get into. Whereas for aerospace engineering, it's a whole lot more specialized. But even software engineering, there you can get pigeonholed if you're not careful. Yeah, you could say you're a software engineer, but then people ask, okay, do you have, do you do firmware? Do you do applications? Do you do like mobile apps? Are you a database programmer? Do you have C++? Do you have Java? Have you worked with, and it's real easy to get pigeonholed. Yes, we're looking for programmers, but they must have Oracle SQL. So.
Another thing is, I know coding isn't the funnest thing to do when you have to sit at a computer screen for hours and whatever. How did you learn to deal with all the, working on code and stuff like that, with it being what it is, like staring at a screen?
Well, there is a lot of staring at a screen. But that's not all there is to software engineering.
Yeah.
Especially with what I do. In the office where I work, there is a target drone about 18 feet long sitting up on blocks right over there in the corner. And occasionally, I have to go do stuff with it. Occasionally, I have to say, okay, I'm going to go flash my new version of the software onto the flight control box that's right there. I'm going to power that thing up. You don't power up the engine. that has to happen elsewhere. But you power up all the electronics on it, and you try that, and then so did that do what you want it to? So then you have some questions that you have to give to other people, and you run upstairs and you talk to some of the designers that work up there. So you're not always at your desk.
Yeah.
Not only that, this particular company that we work for, they've got two facilities in the Sacramento area. Up in Roseville, that's the office where I work at. And that's where most of our designers and most of our software people work. But there's also our factory, which is on Raleigh Boulevard in North Sacramento. It's kind of on the opposite side of Old McClellan Air Force Base. And that's where they actually construct these things. And occasionally, especially when we have a big testing push, occasionally I get to go down to the factory and get to work on some of the planes that are partially completed down there. We run some testing down there. I have been present for some engine tests, where they have a specialized outdoor room, 4 walls, no roof, and they basically chain the plane down so it doesn't go anywhere, and they fire up the engine. And it's not a big engine, but when you're standing, 30 feet away from it, even if there's a concrete wall between you and it, the whole building is just rumbling. So, and occasionally some of our software engineers, in fact, get sent down to Point Mugu or out to the Nevada desert, and they are on our deployment teams where we actually fire them off. Now, I have not been on one of these trips, but many of my coworkers have, and it's like, whoops, something went wrong, and so we have to fix it while the plane's still on the ground before we launch. And so, okay, power it down, and okay, why don't we just swap out the transponder because we don't think that one's working properly. So put a new transponder on, and okay, it appears to be working now, and so forth. So there's a fair amount of uninstalling and reinstalling the actual physical equipment on there. So we're not just at our desks all the time.
So what kind of ideals did you have, like, growing up or going through college? Like, what kind of mindsets did you have?
Well, what kind of ideals did I have? I'm not sure quite how to answer that. See, I was not the most diligent of students. I like to think that I'm reasonably intelligent. But one of the things that can really bite you if you're not careful, if you are a very intelligent person, if you are reasonably intelligent, is that you don't necessarily have to work to get a grade. So when I was in high school and in college, I could whip out an essay. I'd realize first period, oh wait, I've got an essay due 4th period and I've not worked on it. So I would pull out a sheet of paper and the teacher would turn his back and I would look back up and he's talking about something, and then he would turn his back and and I could write. I was a reasonably good writer, and so I could write a decent essay, and by stealing every spare moment while the teacher's back was turned, I could knock out a B+ paper and have it ready by 4th period. Now that works when you're in high school, but it doesn't work when you start getting into college. See, all my classmates, they may not have been able to knock out a B+ paper when the teacher's back was turned between 1st and 4th periods. So what they would do is they would actually do what you're supposed to and do it the night before and actually sit down at the table and think about it and spend time doing it and so forth. And so these other students had learned how to manage their time, and I didn't. And so I was able to coast up until about halfway through my college career. And then I wasn't able to coast anymore, and I, at that point, didn't have the study habits that I needed. So I wasn't the best of students, and I've had to basically fight my bad habits ever since. So take my advice, do it right. Do it right while you're still young.
Yeah.
I need to set my phone up on a charger because it is at 4%.